Welcome to Lesson 3, Radiated Signal Fading. There is an interesting physical phenomenon. As you can see on the slide picture, every time you double the distance from the radiation or signal source, the radiated signal intensity on our body decreases 4 times. So the more distant we are from the transmitter, the radiation intensity on our body will be reduced. Let's imagine here we have a speaker on a picture, and the speaker size is 1 meter. If we move away as far as the size of the speaker, which is 1 meter in our case, the signal intensity on our body will be reduced 4 times. If we move away twice as far as the size of the speaker, which is 2 meters in our case, the signal intensity on our body will be reduced 16 times. Okay, now let's look at some practical examples in upcoming slides. Fluorescent light bulbs come in different sizes and shapes. As you can see on the picture, there could be other bulb shapes and sizes which are not shown on the slide. Fluorescent lights can emit ultraviolet and X-ray radiation, which can be harmful in close proximity. What does it mean? It means that radiation intensity from a light bulb depends on manufacturers' adherence to quality standards. Now we have a workaround for fluorescent lights. First, keep a safe distance from a light source. Second, replace the fluorescent light bulb with an infrared or warm-colored LED lamp. Let's observe an example of radiating signal fading, the theory of which we have discussed on the previous slide. Let's say we have a fluorescent light bulb which is 10 centimeters high as shown on the slide, and we have a 10 centimeter tall person who is initially standing next to the bulb and receives maximum possible radiation on their body. Every time we double the distance from the bulb, the intensity of the radiation will be decreased by a factor of 4. If we double the distance again from the bulb, which is 10 centimeters in our case, we will get an overall distance of 20 centimeters and 16 times reduction of radiation on that experimental human body. So initially, if a human body is right next to the lamp and the size of the lamp, the human body will be exposed to the radiation of 100% without any losses. When we increase the distance to 10 centimeters from the lamp, the radiation on that human body reduces 4 times. And when we increase the distance to 20 centimeters, we can observe a reduction in radiation 16 times. And if we again double the distance, we can observe a reduction in radiation intensity 64 times. So by moving away to 80 centimeters, we can observe a reduction in radiation intensity 256 times. By moving further from the bulb, the human body will get less radiation intensity. From the described example, we can understand that one of the most effective ways to reduce fluorescent light radiation intensity on our body is to increase the distance from the radiating object. Another workaround is to avoid using fluorescent light bulbs near your desk altogether. As stated previously, we can use old-style infrared or warm-colored LED lamps instead. In this way, ultraviolet or X-ray radiation from fluorescent lights will be minimized or completely eliminated. In Lesson 4, we are going to compare the electronic devices' radiation intensity to an LED radiation intensity. So see you in upcoming lesson.